Okay, so now we have an introduction to Spark. To Apache Spark is another framework or platform, so to speak, that was created after Hadoop MapReduce. Basically, the creators of Hadoop MapReduce noticed some of the limitations of MapReduce when we have algorithms that require multiple iterations. And so multiple iterations didn't work very good with MapReduce and other performance issues. And so to solve these problems and to provide a faster computation for large amounts of data, the Spark was created. So Spark is pretty much another platform. We will see how it looks like. So what we will talk about is how the Spark is designed. So what is the software stack for Spark? So we will see the platform and the packages that can run on it, or the different libraries that it has. The building blocks of the Spark are these resilient distributed data sets. We will look at what they are and how to use them, and see how a Spark job can be run at on a cluster. So what is Apache Spark? It is a fast general purpose cluster computing framework. So it is a framework or a platform similar to the way Hadoop is a platform that creates a cluster of computers that can be used for data processing. However, the difference here is that it is fast and general purpose. So it is believed that this Spark will replace MapReduce in the future, and that MapReduce engines might become outdated and retired. So pretty much Spark is the fastest cluster data analysis platform that we currently have. It does not use MapReduce in the background. So when we have seen this Hive program, it does create MapReduce jobs in the background. Spark does not use MapReduce at all. It is as an execution engine. It can be integrated with Hadoop, so it can use the Hadoop distributed file system HDFS, and it can run on a Hadoop cluster if we have Yarn. So Yarn is the new version of. So if we have a Yarn, it can run on that, as well as it can run on its own or on other cluster in platforms. It can run on top of Hadoop and use the HDFS as a storage. The main advantage of Spark is that it can persist large data sets in memory between jobs, which MapReduce it cannot do this. So if we have multiple jobs that need to share data and transfer it between each other, then MapReduce is not very efficient with that. On the other hand, Spark is able to cache and keep data in memory while it does processing in between multiple jobs, and that is pretty much the reason why it is so much faster than MapReduce. The programming language it's written is Scala, and Scala stands for scalability. However, we can use other languages to program Spark. We can use Java, Scala, and Python to program it. They are currently working in supporting the R language also for Spark. So how does the Spark software stack look like? So this is the Spark core, where is the cluster manager. So the core is where the jobs are managed and scheduled, and also this is where the resilient distributed data sets are residing, and which are pretty much the basic unit of data for Spark. The Spark core can be installed as what's called a standalone mode or standalone scheduler. In that case, there is no specific software required to create cluster of computers. Spark can do this on its own. So basically, you can take a bunch of empty computers and install it on them, and it will create a cluster, and it will do its own scheduling of jobs in that case. Yarn, this is Hadoop Yarn. It can be installed on top of Hadoop Yarn if we already have Hadoop installed in our cluster environment, and we can put Spark on it. That is what we have on our Hadoop cluster here, on the Hadoop SBA cluster that you logged in today. We have installed on top of it the Spark core. So basically, when you log into the Hadoop DSBA, you can run Spark there. And this is the Apache Mesos. It's just another platform for clustering. It can be installed on that as well. It does support the Hadoop distributed file system. It integrates with it, so it can fetch files from HDFS as well as other file systems such as Cassandra and the Google file system and others. What are the core libraries that Spark has? So it has 4 libraries that power packages that it provides. The first one is the Spark SQL. So Spark SQL, the standard query language, is Spark has a library for processing structured data. So if we have a table with rows and columns, like the one we did in our exercise, we can create a table in Spark and run the SQL query. Just like we did in Hive, we can do the same thing in Spark with the Spark SQL library. Other libraries that it has is for streaming data. So it supports some major streaming sinks such as Kafka and Flume, which are sources for streaming data. And it can do processing on real-time live data that comes in pieces, such as the streams. So that is also another advantage over MapReduce, which is not performing very well with that. And that is why we had these separate streaming tools that ran on top of it, like Storm. In this case, we have a built-in streaming package. Another important part of the Spark is its machine learning library. So there are some pre-built methods for major machine learning algorithms that exist and that can be run for data analysis, such as clustering of data, decision trees, support vector machines, and many other tools that are used in machine learning. GraphX is another library that the Spark provides for processing large graphs. So why would we want to process large graphs? So imagine the Facebook as a graph. Let's say each Facebook user is one node or one circle in the graph, and it is an arrow when it connects to another person as a friend. So if we take all the people on Facebook and connect them with arrows, That's pretty much a graph. And if we want to analyze that graph, let's say, find out who are the people that play basketball or who are the people that go to UNC Charlotte, then we can use the GraphX to analyze huge graphs like that. Let's say we want to find communities in the social network, or we want to, let's say, do PageRank. We can represent all the pages in the web as a huge graph, and that have links to one another. When they actually include links to another page, we link them together on a graph to show the links that they have. That's another huge graph, the entire web, of all the web pages on the web. And that's what that is designed to process. As I mentioned, there are several languages. It supports Scala, Java, and Python, but also it has support for the R language.